Hello there. It is June 3rd, 2025, and this is the libhal biweekly meeting. For the agenda today, we're going to go over a couple of items. First off, we're going to talk about getting all of the CI passing for libhal. We'll also talk about a couple of things that I kind of learned from that. A couple of things that we've also improved because of this is improving the library compatibility. I basically figured out why spuriously, out of nowhere, some binaries would not build with other people's code. I thought this was an issue with just how people were using Conan, and I realized that's actually not the case. I'll also talk about additional options for the ARM GNU Toolchain. Originally, I had no options for the toolchain because dealing with options in Conan was a bit difficult for tool packages, but then I discovered that you can actually still propagate option information through. And I'll talk about that next when I talk about the new feature to Conan profiles called the context feature. So first off, I spent a good portion of last week just working on getting all of the CI workflows for all of the repos that are listed here running. There are some other repos that aren't currently working, but we're not putting as much effort into them. One that's not listed here is actually just the FreeRTOS port for libhal. That's not included here, but that's also passing. The reason why I wanted to make this happen is that I understood that there were some issues with our code. And I've always been able to kind of massage and talk to people and then figure out what they had wrong on their system and then fix things up. But there were a whole bunch of weird, basically failures happening here and there. And after a while, I was like, okay, something seems to be systematically wrong. I need to go through all of the CI and figure out exactly what's causing each and every one of them to go wrong, because there might be something that I'm missing. And in the end, I ended up finding out quite a few things that I was missing and quite a few features that I wanted to bring into libhal, as well as how some things got reshuffled. The first thing I'm going to talk about is how we improved library binary compatibility. I did not know this. I don't know how I missed this, but it is spelled out in here that the patch number is the only number that keeps compatibility with Python packages. If the minor number updates, then the binary compatibility between one package and another package becomes different. I don't know if I fully understand the rationale for that, why they made it a little bit more different. But that's just how it is. So kind of zooming in a bit, what they tell you to do is when you do Python requires, and if you want like the normal like caret operation of I want this to be compatible with or in forward compatible with, but also less than the next version, you just have to do this. So greater than or equals to the current version you have, and then less than the next version. And whenever you actually change something, you just change this number. You keep this. You do not touch this number until you actually break the major number, and then you can update both. By changing this on all of our libraries, which I systematically did in the last week, from now on, when we do upgrades to libhal bootstrap or any other Python packages, that will not break our build and that will no longer cause any binary compatibility issues. All right, so from this, I also took another look at the ARM GNU Toolchain. For a client, I was actually doing some work where I wanted to utilize the ARM GNU Toolchain because I've been building all my stuff with it. Makes my life really easy. Doing things through the shell or doing things through make or CMake directly. Pain in the butt. That's why I put all this effort into Conan. So I was like, all right, I want the ability to be able to like download my own directory for my toolchain, so I can like build on that. Different versions, just kind of, or build my own versions. So one of the first things I worked on was local path. So I know there are certain individuals in our project that build their compilers and stuff like that. This is a way to bring that compiler into libhal, and it's actually super quick. So normally when you run Conan create all for the ARM GNU Toolchain, it'll go and download the files from the ARM official website. Using this, if you already have the binaries on your computer, you can just point them over and the build for this becomes super fast. So you can also set your own local path, and this allows you to basically override whatever version you want with your own version on your computer. Really helpful if you are going and messing with things, changing stuff, modifying what the libc++ standard has, or like what libc is defined as, and that kind of stuff. This makes it really easy to test out those changes. All right, so next up, there's the default arc. So one of the things that the ARM GNU Toolchain does for you is if you use it, and you have to, but if you use it, when you also set up your architecture for the chip that you're supporting, and it would be one of these in this list. And this might not be a complete list. If there are more, we'll add more in the future. I know we're missing quite a few hard float versions of the 33 and the 55, but aside from that, the user or the user of this particular package may not be interested in using our exact flags. They may want to use a certain specific set of flags that they've trusted, been using for years. It does a very specific thing for them. So this allows you to toggle that on and off. So if you, by default, everything here is on except for local path, so everything here is true. But yeah, for default architecture, this will automatically inject the appropriate flag, so your code doesn't have to do that. You can just hopefully write generic GCC or Clang, or sorry, not Clang. I don't know why I'm saying that. This is obviously the ARM GNU, the GNU toolchain. But yeah, you can put whatever GCC flags that you'd like in there, and it'll just work. You don't have to really worry about the more architecture-specific stuff. You may need that for your own use cases, but in general, we try to make sure that it doesn't need that. Next up, we have LTO and fat LTO. Fat LTO only works if LTO is enabled, and LTO stands for link time optimization. I don't know why I hadn't turned this on in the past. I have had problems in older versions of GCC where turning on LTO and using the nanonewlib implementation, the default like small C library they have for embedded, for some reason would result in certain functions being removed from the code base, or like removed from the code, and then just my code would just freak out when it tries to execute. I'd also get like random seg faults at random spots, and I never really dug into why that was. Now we use picolibc, and when I turn back on LTO, it seems to work just fine. I'm also using a much later compiler. I think that might have been having these issues at like GCC 9, maybe 10, but we're at 12. Well, actually, we're at 14 for ARM GCC. I'm currently using 12.3. I haven't had any issues. Here's the important thing about LTO. I think I might have said this before, but I'll say it again. Link time optimization basically puts a different representation of your code into, basically compiles your code into a different intermediary step. The linker can then use that information from that in order to figure out, oh, well, if I just take this code and this representation of the code here and just inline it in this spot, I can make the code faster. So normally, a lot of the optimizations that C and C++ do happens within each file, so within each translation unit. So there's a barrier to how much you can optimize. If you have functions defined in different files, and they won't be able to be in line with each other, they don't know what their definitions look like. With LTO, you can actually do that. So that's kind of the thing that you get from LTO. It's able to see the entire program and make optimizations at a global scale. Now, what fat LTO does is this also compiles both the LTO information and the original object compiled assembly. By supporting both, I think they're interoperable. Like the linker can understand how to look at the object file like a normal object file, and the LTO system has a way to determine, oh, we're both. The cool thing about this is that we could make our objects work with either side. It'll make compile times a little slower, but it'll work either way. So that's LTO and fat LTO, and these are all set to default true, because I think that there's no reason for us to not turn this on for our users. It's gonna make their lives better. It's something they don't have to discover themselves. It'll make their binary smaller. And I think a lot of them are not gonna care about their artifacts being large. I think most embedded developers do not care about that very much. Also, this doesn't change anything about the actual code. It just really optimizes it. And lastly, we have one more additional thing that enables further optimization and does not alter code. So function sections, data sections, and GC sections. So function and data sections are basically the same thing, except they take every single function and every piece of data and they give them their own section block. This allows the linker to be able to relocate and or destroy blocks of code. So the way that the linker usually works is that you have your functions, you compile them all down, and you have a symbol for each one of those. Now, old school C code would like bundle them up all as one big block. So if you called into one function in that block, you would have to pay for the entire function's block. So even if there are additional functions that you will never, ever, ever call, the linker has no idea how to differentiate. It just sees one big block of functions and it says, hey, you need that block, so I'm going to put the block in there. This subdivides all the blocks to their smallest components so that they can be maneuvered, removed, or related into each other. And the GC sections is the command that's given to the linker to tell it, hey, take advantage of the fact that the functions and the data sections are made. These have to be done at the compiler level, otherwise the information linker gets isn't sectioned enough. And this needs to be given to the linker to tell it to actually go in and pull out the data. Again, these don't change your code whatsoever. This doesn't really even change any optimization. It just simply allows the linker to optimize if it wants to. So again, I think this is a good aspect to have our binaries have by default. All right, and then another thing that came up while I was doing my development. So at some point, I had the libc profile. I had an option for libc. So in this list, there was also a libc section about whether or not we should use the default libc or not. I put the default libc as nano. I did that because I felt that made sense to some degree for the embedded cases. This ARM GNU Toolchain might be used beyond just that. I might start supporting all of the ARM toolchains because why not? I mean, if people have demand for it and that's somehow valuable to us, then I think there's no reason to not extend this to that. So that option felt weird to have, that I would make some sort of default for people, kind of like the ARC map. So maybe if there are a set of defaults that people think works best for this, then we could do that. But in general, I think that it's very application specific. So I was like, okay. And it's only a link step. So it's one of those things that like any application developer can choose at the last step of their build. It's not like we need to build all the files with the libc in mind. So when I got to thinking about that, I realized that it wasn't a good spot in here, but originally I wanted that. So I pushed really hard to figure out if there was any way to make that happen. And eventually I realized that there was a feature missing in Conan that would be nice if they had. So basically, I was asking them, they have this capability to give variables into the profiles. So when you say like -pr STM32F103, and then you also put in your ARM compiler, you're injecting information into the build system of Conan so it can do things. What I wanted was a singular profile that could both inject build profile information and host profile information. So here's the thing that I learned. These options here, because they are a tool package, not a normal package, but a tool package, can only be modified from the build profile context. The host profile context explains like what this thing is and how you're going to build down to it. So this is where you say the host that's going to run this code is going to be the Cortex M3, and the build type is going to be minimum size. Whereas for the build itself, we want to say that, hey, to the ARM GNU Toolchain, I want you to set fat LTO to false for some reason. Now you can do this already if you just add yet another profile, but that kind of sucks. That's a lot more typing, and I already feel like having two is a lot, but I cannot split those. I can't put those together, the compiler and the target, because that makes bad defaults for people. I want people to kind of choose what they want. They can combine them if they want. But having to do three was really annoying, and I didn't like the idea of having to then also maintain all the other profiles for the different ways we want to set this up. So I asked them for the feature, and they actually put it in. So that's going to be happening on the next release, probably updating some stuff to feature that. Yeah. And that's pretty much it for this meeting.